Hello everyone, welcome back to Diksha Vedantu Foundation channel, and today is day 52 of 99% in 99 days. Today we are going to cover the previous year questions from the chapter Electromagnetic Effects of Electric Current. This is a small chapter perspective of this course because even though it's an important chapter, the content of this chapter is small. Many of them are deleted in the current syllabus, so we will only be solving the questions which are relevant for your final exam, right? And also happy new year to everyone. I know there was some delay happened for last 1 or 2 videos because of the new year celebration was going on, so don't worry, we will be uploading videos regularly from here on as much as possible to help you achieve that 99% in 99 days, right? So what all we are going to discuss today, as I said, this is a small chapter, so only 3 previous year questions I could find in the MCQ section, including assertion and reason based questions. Don't worry, we will compensate that when we are doing questions, regular questions, not PYQs. Okay, because this is PYQs, I have kept the questions which only I could collect from previous year question papers. When we do general questions, then we will cover that more number of questions from this chapter, right? Question 4 and question 7 is short answer type 2 marks question. Sometimes they can be asked as a 3 marks question as well. Then question number 8 to question number 10 we will be solving long answer type questions. So only 10 questions we will solve today, so this will be a very small session, so don't go anywhere, wait till the end. First question that he is given is the correct pattern for magnetic field lines of the field produced by a current carrying circular loop is. So as you can see, all these diagrams, they are all having the same thing. Current is entering from here, current is getting entered from here and coming out from here, and all the diagrams are very close to each other with slight difference. First of all, there are some circular symbols on top. Here there is no circular symbol, so definitely this is not correct, this is incorrect. Here they have given the circular symbols but nothing is given, no lines are given here, so definitely this is also incorrect. So this is not correct, these two are not correct. So out of these two, which one is correct, we have to see. All the directions of the arrows are also same direction. Only difference is that if you see here, we have a clear gap. Okay, here we have clear gap between the central line and all the other lines. Here if you see in this region, all the lines are overlapping. So all the lines are overlapping means the magnetic field lines are crossing each other, which is not possible. Magnetic field lines cannot intersect each other, so this is not correct. So definitely this is the correct answer. So by the method of elimination you can answer it. If you know, okay, this is the correct answer, definitely you can answer it. Otherwise, by the method of elimination you can ignore, okay, this is not correct, this is not correct, this is not correct, this is correct answer, right? Now next question, the magnetic field inside a long straight current carrying solenoid. This question is directly taken from your textbook, and also it came in outside Delhi set 2023. So magnetic field lines along solenoid, if the solenoid is long, magnetic field lines inside the solenoid is constant. Okay, magnetic field lines inside the solenoid is constant except the edges, except exactly at the edges. Okay, magnetic field lines anywhere inside the solenoid is always constant. Okay, so is same at all points. It's same at all points, does not decrease, does not increase. Okay, it remains same because field lines are parallel to each other. We will see in a while of the diagram. Okay, there we will see how they are parallel to each other and why they are considered to be constant. Now next is an assertion reason based question. A current carrying straight conductor experiences a force when placed perpendicular to the direction of magnetic field. Okay, current carrying straight conductor experiences a force when placed perpendicular to the direction of magnetic field. So current carrying conductor, magnetic field, okay, there will be some force. We can calculate the direction of force using Fleming's left hand rule. The net charge on the current carrying conductor is always 0. Okay, the net charge on a current carrying conductor is always 0 okay, you can say that, but even though the net charge on a current carrying conductor is always 0, yes, it is correct, but it has no relationship with the assertion. So both assertion and reason are correct, but what is the relationship between assertion and reason, right? So both assertion and reason are true, but reason is not the correct explanation for the assertion. This is the correct answer, right? So option B is the correct answer in this case. Now why this is true? Because if you consider that there is a conductor, okay, and you applied a potential across it, okay, the charges which are there inside the conductor, they will be accelerated in a particular direction. So number of electrons which is being supplied by the external voltage, that only will pass through once on the other side, right? So at any time, if you look into the conductor at any point of time, the total number of electrons and protons present inside the conductor will remain constant. That's why even though the conductor has been kept under the influence of a potential difference, only the potential difference is responsible for the flow of current, not any excess charge. If you charge it separately by static electrical methods, then it will have excess charge. Otherwise, when it is carrying current, it will not have any excess amount of charge. Next question, short answer type 2 mark question. State 2 important advantage of using alternating current over direct current. So as you know, in our household we use alternating current over direct current. What is direct current, what is alternate current, that also we will discuss in our next few questions, but let's see what are all the advantages. It is more efficient for long distance transmission. Previously there was a long paragraph written about AC and DC, which is not part of your current syllabus, but AC and DC are mentioned and small information is given. So that's why this question still might come as a higher order thinking question. Okay, it is not more efficient for long distance transmission. So AC is more efficient for long distance transmission. AC system can use transformers to easily step up or step down the voltage level. Suppose you are using a device which requires, say, 440 volts to operate, okay, but your supplier, the current that is coming to your house is only 220 volt. So what they will do, they will have a voltage regulator inside that device. So that device will automatically regulate the voltage to 440 volts, okay, and whenever voltage level drops, it will try to adjust that same voltage. Voltage can be changed based on the requirement. Current can be also changed, right? So based on what is your requirement, current and voltage can be step up and step down using a device called transformer. Many electrical devices use transformers, okay. So that's why even transformer that is located outside your house, maybe in your locality, that also is a transformer that reduces the incoming voltage from the power source, power stations, okay. Power stations supply generally high voltage that is being reduced gradually. By the time it reaches your house, it is 440 volt. From there the local transformer reduces it to 220 volts and then it is supplied to your house, right? So the voltage can easily be increased or decreased based on the requirement. That's why AC is more popular. In case of DC, to increase the voltage you have to use some other complicated mechanism which is costly also. You will lose out a lot of energy during that process, which is not so in case of AC. Next, state the rule to determine the direction of number 1, magnetic field produced around a straight current carrying conductor, and force experienced by a current carrying straight conductor placed in a magnetic field which is perpendicular to it. Outside Delhi set. So right hand, first thing is what law we use? We use right hand thumb rule. So you put your thumbs around in the direction of current, okay, and wrap your fingers around the current, then you will get the direction. So if the current is flowing in this direction, you put your thumb in the direction of current, wrap your fingers around it, okay, then you will get the direction of magnetic field line. So point your right hand thumb. Very, very important is that this is for right hand thumb rule. That's why it is called right hand thumb rule, okay, not the left hand thumb rule. point your right hand thumb in the direction of the current through the conductor, curl your fingers around the conductor. The direction in which your fingers curl, okay, indicates the direction of the magnetic field lines around the conductor. So very important law to remember. Okay, if you in future if you study science, obviously in physics, in your class 12th, you will use this law again and again. Okay, so you curl your fingers in the direction. First you point your thumb in the direction of current, curl your fingers, then whatever is the direction of your fingers, that is the direction of the magnetic field line. So in this case, magnetic field lines points like this. Okay, now next law is what? Next law is Fleming's left hand rule. Obviously, stretch the thumb, the forefinger and the middle finger of your left hand such that they are mutually perpendicular. So you stretch your thumb, forefinger, middle finger so that they are mutually perpendicular. You can see that they are mutually perpendicular. Okay, now what? If the first finger points in the direction of magnetic field, okay, first finger means this. If your first finger points in the direction of magnetic field and the second finger is in the direction of current, then thumb will point in the direction of motion of the force acting on the conductor. So first finger in the direction of magnetic field, second finger in the direction of current, then thumb will point in the direction of force. So suppose there is a magnetic field in this direction, a current is passing through this in this direction, then thumb will try to push it upwards. Okay, basically that is the meaning. Suppose there is a conductor carrying current in this direction, you have put some magnetic field in it. Okay, then this conductor will experience as a force in the upward direction. So it will start moving in the upward direction because of the Fleming's left hand rule. Right, that is the Fleming's left hand rule. Now next question, when is the force experienced by a current carrying straight conductor placed in an uniform magnetic field is maximum, is minimum? So let's see, maximum is when the conductor is perpendicular to the magnetic field. So when the conductor is perpendicular to the magnetic field, the force is maximum. Minimum is the conductor is parallel to the magnetic field. So for maximum force only we know Fleming's left hand rule. So when they are perpendicular to each other, the force is maximum. When they are parallel to each other, force becomes 0. Okay, so when they are parallel to each other means both are pointing in the same direction. So in that case, no force acts on it. Okay, the detailed reason for this you will learn in the class 12. Okay, so if you are interested, you can mention that in the comment below. I can help you to guide through that where you can find that answer. Right, now next question. List 4 properties of magnetic field lines. Okay, so what are the 4 properties? Always form closed loop. Magnetic field lines are always closed loop. Okay, do not intersect. Obviously magnetic field lines do not intersect. They are density represents strength. So more the number of lines passing through a small area means stronger is the magnetic field. Direction of field is the if you draw a tangent, actually this is incomplete. Direction of field is represented by the tangent drawn on the line. Right, so suppose there is a magnetic field line is like that. I want to say what is the direction of magnetic field line at this point. So what we will do, we will draw a tangent at this point, and this tangent will represent the direction of magnetic field at this point. Okay, sense should be in the direction of the line. So as you can see, field line is moving in this direction, so obviously it will be the direction of magnetic field. Okay, so you can find the direction of magnetic field. You can say if the more number of lines are there in a small region, okay, more number of lines are there in a small region, so definitely it is a strong magnetic field. Okay, compared to suppose this is the field line number 1. Okay, this is field lines number 2, arrangement number 2. So definitely this is a stronger magnetic field, this is a weaker magnetic field because more number of line represents strength. Okay, simple as that. Next question. Why an alternating current AC is considered to be advantageous over direct current DC for long distance transmission of electric power? This is the same question as what we have discussed, why AC is more used in our household. The same reason is why it is used for long distance transmission. Okay, the same reason. What are the reasons? It is more efficient for long distance transmission. Obviously, AC system can use transformers to easily step up or step down the voltage levels. First point, you can say that as it consumes less power. As it consumes less power. Okay, because you can transmit AC current in a higher voltage form. Okay, it is a very high voltage form and low current form. We know that power dissipated is basically, from our previous chapter, power dissipated is I square R, right? And in case of voltage, it is V square by R. So if you increase the current, okay, if you increase, sorry, not V square by R, it is V square by R. If you increase the resistance of the wire, okay, you can reduce the power dissipated in the circuit in case of high voltage. But in case of high current, okay, more resistance means more amount of power dissipation. So we always want to transmit the power in form of higher voltage and very low current, because in that case what will happen, the resistance of the wire will be will help us to reduce the power consumed. Same formula, but because the form is different, we are using voltage form rather than the resistance current form. Power consumed will be reduced in case of AC current in compared to DC. DC you cannot compare it like that. Okay, DC, even if you want to reduce the voltage, you have to use complex machinery, which is very difficult. A simple transformer can be used to change the voltage. Now, what else? How the type of current used in household supply different from the one given by the battery or dry cell. So household supply provides alternating current where the direction of current changes periodically. So alternating current means it becomes positive in first half cycle and then negative, positive, negative, positive, negative, it changes, right? The AC current is like this, right? So this is the AC current. Okay, with time, this is the time axis, this is the voltage axis. So voltage changes over time, that is AC. It fluctuates, but whereas, and the frequency is 50 Hertz. So every second it fluctuates 50 times. The frequency represents the fluctuation in 1 second, how many times it fluctuates. So 50 times it changes its direction in 1 second only. Whereas in the DC current, you don't do anything like that, provides direct current where the current remains in a single constant direction. So it remains in a single constant direction, one directional current only, okay, and one value only. Okay, but in case of AC, the value changes from plus to minus also. At some times, for example, in this positions, it becomes 0 as well. Okay, so AC is not constant, it is fluctuating. DC is constant. Okay, now there are some devices which can operate on AC or DC. Some device requires DC only to operate, but we can convert AC to DC. For example, your mobile phone from where you are watching, or your laptop device from where you are watching this video, they work on DC current. Okay, so what is the role of the charger? Charger basically converts the AC into DC. That's it. So simple charger can convert AC into DC, but AC is most commonly used by most of the devices. For example, normal incandescent bulbs, fans, okay, normal ACs, even normal fridge, they can all operate under normal AC current. Okay, there are obviously smart TV, smart LEDs, smart lights, they require DC, but they can be converted into DC quite easily. Okay, that is why AC is more commonly used rather than DC. Okay, but because if you are using DC, then you have to change all of your other devices. Okay, maybe charging your mobile phone will be easier, but switching on the fan, switching on the AC, switching on the refrigerator will be difficult. So you will need a new kind of circuit. Every device has to use a new kind of circuit. So that's why AC is used, because AC can be easily converted into DC, and all the devices that requires DC, they are configured such a way that they can easily convert that AC into DC. Okay. How does an electric fuse prevent the electric circuit and the appliances from a possible damage due to the short circuiting or overloading? Let's see. An electric fuse protects an electrical circuit and connected appliance from damage due to short circuiting overloading by interrupting the flow of the current when it exceeds the safe level. Basically, a fuse is a device of low resistance, right? We already learned about it in our previous chapter a little bit. Okay, and a fuse is basically a low resistance conductor, okay, and has a low melting point as well. So whenever a high amount of current passes through it, it produces enough power. Due to that power, fuse gets burned, and by burning it, it disconnects the circuit. By disconnecting the circuit, it prevents for any further damage of the connected device, right? So basically it burns itself to save your device, right? And what if you I mentioned during my class that nowadays we do not use direct fuses, except very few appliances. We directly do not use fuse, we use a new kind of device. If you know the name of the device, mention in the comment below. I already told you the name of the device during my regular lecture. Right, now next time for the next question. For the current carrying solenoid as shown, so there was the image given for a current carrying solenoid. Draw the magnetic field lines and give reason to explain that out of the 3 points ABC, at which point the field strength is maximum and which point it is minimum. So there was a diagram like this. You have to draw this diagram. Okay, and between the points A, B, C, as you can see, magnetic field lines are most concentrated in this area, right? So magnetic field lines is, the magnetic field is strongest within the core. Okay, and as you are slowly moving out, it is decreasing, and it is least in the region where there is no field lines. Okay, in this region it is very low, in this region it is okay, and it is strongest within the core. The strongest within the core. So magnetic field lines is always strong inside the solenoid, okay, and it slowly decreases as you move out of the solenoid. Okay, it in the perpendicular direction it is decreasing rapidly, whereas in the longitudinal direction along the axis of the solenoid it decreases, but decreases slowly. Okay, that is the answer. Now next question. What is a solenoid? A coil of many circular turns of insulated copper wire wrapped closely in the shape of a cylinder is called a solenoid. Draw the pattern of magnetic field lines of a current carrying solenoid and a bar magnet. List 2 distinguishing features between the two fields. So first of all, so this is the magnetic field lines due to a solenoid, this is the magnetic field lines due to the bar magnet. Now in this case, the magnetic field lines is dependent on the current. Okay, it is dependent on the current, it is dependent on the number of turns. Magnetic bar magnet is independent of that. It has a fixed magnetic field lines. Okay, you cannot change it for a given bar magnet. For a given solenoid, you can change the magnetic field strength or field lines by changing the current, or by increasing the number of turns, or changing the number of turns. Basically, if you decrease the number of turns, it will be a weaker magnetic field. If you increase the magnetic turns, it will be a stronger magnetic field lines. If you know any other points than this, don't forget to mention that in the comment below. Okay, so this is the main two differences between the two field lines. Now, draw a pattern of magnetic field lines produced around a current carrying state conductor passing perpendicularly through a horizontal cardboard. State and apply right hand thumb rule to mark the direction of the field lines. How will the strength of the magnetic field change when the point where the magnetic field is to be determined is moved away from the state conductor? Give reasons to justify your answer. So the diagram is like this. There is a state current carrying conductor, there is a cardboard, and you have to draw this circle. Okay, and what else? You have to use the thumb rule to find the direction of the field line. So if you apply thumb rule, so this is the direction of current, so into the in this direction, and this should be the direction of magnetic field lines. So in this case the magnetic field lines will be like this, right? So magnetic field lines will be like this. Okay, so magnetic field lines, first step is to draw this part, and then you have to draw the arrows, right? So simple as that. This is very simple diagram based question. Okay, and it is outside the set, but still. Now, how will the strength of the magnetic field lines change when the point where the magnetic field is to be determined is moved away from the straight conductor? So as you suppose you are initially at this point A and you have moved to point B, how will the magnetic field strength will change? So magnetic field strength will change, it will decrease. Okay, it will decrease as you are moving away from the current carrying conductor. Okay, the magnetic field decreases. Okay, give reason to justify your answer. Now there are two ways to give the justification. First of all is your experimental justification. So as you do the experiment, during the experiment we see that number of field lines near the wire, near the current carrying wires are more, they are densely concentrated. Okay, so if you, what is the experiment? If you remember, there is a cardboard, we put some iron filings and we started the current, we tap it, so there are some circles formed around the current carrying wires, and more, the circles are more near the wire than as you move away from the wire. Okay, so the circles are concentrated near the wire and they are less concentrated as you move away from the wire. So that is the first explanation, but that is not complete explanation. What you have to say that the magnetic field is inversely proportional to the square of the distance. This is a little slightly high level stuff. So magnetic field is inversely proportional to the square of the distance. So as you move away from the wire, the magnetic field strength decreases. That's it. Because they have not mentioned anything else, how do you know this? It's not matter, but you have to know that magnetic field is inversely proportional to the square of the distance from the center of the wire. That's why as you move away from the current carrying wire, the magnetic field will slowly decrease. Okay, clear? Now if you have any doubt, don't forget to mention that in the comment below. And if you have any doubt in your future, what you are planning about your future, you are so confused, then obviously here we have Diksha Scholastic Aptitude Test or DSAT. It is getting conducted every Sunday on our Diksha campuses. The link of this is given in the description. What you have to do, you have to fill up this form and our representative will contact you. Now what is DSAT? DSAT is basically a 60-minute lecture plus your doubt clarification. Once that doubt clarification is over, once the lecture is over, doubt clarification is over, based on that lecture you will be given an 1 hour aptitude test. Okay, once the aptitude test is over, based on that result of your aptitude test, there will be a counselor who will guide you to achieve your dream. Okay, maybe you are thinking I am useless, I cannot do anything in my life, but if you attend this session, after this session, that will be an eye-opening for you. A lot of new possibilities will open for you. Okay, whether you should choose to study to become a doctor in future, that is you have to prepare for a NEET exam, or you want to become a engineer in future. For that you have to study and crack a very important exam called JEE. You may have heard about it. Or you are from Karnataka, obviously we have campuses only in Bangalore, and you are in Karnataka, you want to excel in Karnataka, you want to take admission in Karnataka engineering colleges. There are a lot of world-class engineering colleges in Karnataka, so you should focus more on KCET exam. So based on your aptitude test, the counselor will be guiding you for your best career options. So what are you waiting for? Fill up this form. The link is given in the description, and I will be back with a new video. Till then, bye.